Okay, this video is for 11.1G, Circumference and Arc Length. So in class this week, we talked about circumference having the formula either 2 pi r or circumference is pi times d. Now the reason it has two formulas is because it works with the diameter. So pi times the diameter will give you the circumference. But the diameter is also 2 times the radius. So we can substitute in 2r for d, and then we'd still get the same answer. So, depending on the information they give us, we're going to use a specific, or one of those two formulas. So let's look at problem number 1. It's telling us to find the circumference of a circle with a radius of 6 inches. So it tells us to find the circumference using the radius. So that's going to be our first equation. So the circumference would equal 2 pi r with a radius of 6. That would become 2 times pi times 6. And plug that straight into your calculator and you get 37.7 inches. And that is our answer. Alright. Let's do problem 5. So now they give us a circle, and they want us to find the circumference and a couple arcs as well. The circumference is going to work with either 2 pi r or pi d, so we can use either the radius or the diameter to figure out the circumference. And then for us to find lengths of different arcs, so arc AB or arc ACB, we want to use the circumference equation, but multiply it by the ratio of the diameter, or the ratio of the circumference we're using. So for instance, arc AB is this arc right here. And that is 90 degrees out of the total 360 degrees. So our equation would look like this. 90 divided by 360, and multiply that by the circumference equation, which we know the radius is 7, so we would say 2 pi times 7. And after we plug that into our calculator, we get 11.0. Alright, so if that is 90 degrees worth of the circle, then the remaining circle, which is arc ACB, has to be 270 degrees of the circle. So we would use the same formula, except for we would do 270 divided by 360, and then multiply it by our circumference. And that equals 32.99. And then finally, just for our total circumference, we do the 2 pi times our radius. In this case is 7, and that gives us 43.98. Alright. What else do we got? Let's go do one on the back. We'll do problem number 15. Gives us a diagram of a basketball free throw area, this place right here, and it wants us to find the perimeter around the area. Or the perimeter around the basketball area. So that's going to be this 15 feet right here, plus this 15 feet, plus this 12 feet, plus half of a circle to get this top piece. So the 15 plus 15 plus 12, that's pretty simple, but we need to figure out what half of that circle is. Perimeter of a circle is another word for circumference, so we need to figure out what half the circumference of that circle is. Well, you can see that the diameter of the circle has to be equal to this 12, this distance of 12. So for us to find the circumference, we can use pi times d, and d is 12. So pi times 12 equals 37.7. And that would be the circumference of the entire circle. But we only want half that. We only want this blue half. So we have to divide that by 2. And 37.7 divided by 2 is 18.85. So that's the perimeter of our blue circle. And now we just want to add to it 15 plus 12 plus 15. And that'll give us the perimeter of the whole area. So 18.85 plus 12 plus 15 plus 15. And that all equals 60.85. And that's our final answer for the perimeter of the basketball area. And what is the perimeter around just the circle? Well, we already figured that out. The perimeter around just the circle is the overall circumference of the circle. So that's pi times the diameter, which we said was 12. So that equals 37.7.